If we're dilating away from the y-axis first, so a point x comma y goes to a point 2x comma y, what matrix will we multiply by to get from P to P?
2010. No, 2001.
Excellent. 2001 will be a dilation away from the y-axis by a factor of 2. And obviously if you wanted a factor of A, it would be A001. And equally there for part B, if we were taking that, which in orange down here is x is going to x, but y is going to 4y, then excellent, 1004 will take us away there. Happy? So this is actually just simple versions of those linear transformations, but these are specific ones that you've seen before. And we can apply these to functions. So you could get a function now, y equals x squared, and apply a transformation on a common point, so a pxy, to that function. Now away from both the x and the y-axis, let's say away from the x-axis by a factor of a and the y-axis by a factor of b, what function will we use now? Easy? Done. Cool. So, oh no, actually it should be reversed, shouldn't it? That should be the other way around. B00A. Away from the x-axis, we multiply the y-coordinate, because it's the one that changes. Example 2. Determine the transformational matrix that would take each vertex in a unit square and dilate it to be a 5 by 3 rectangle with the bottom left vertex at the origin. You've got to make a slight assumption here.
Unit square.
Yes, the unit square.
That's not too hard, I think.
So the unit square looks like this. There's my graph. Here's the unit square. That's 1, 1. That's 0, 1. That's 1, 0. And this is 0, 0 here. And the unit square is being dilated out to this purple rectangle, which goes to 5, 0, 5, 3, and 0, 3, and obviously 0, 0. So it's going out to that new rectangle there. So what will the matrix be? Any takers? What's the matrix that's going to do this expansion? 5003, cool. If somebody said that, I'm sorry, I just didn't quite hear. 5003, and we talked about this last time, we don't have to do unit square as individual points. We can combine them as 4 points, and we could now do the rectangle will be equal to t times us, the unit square, and that will give us those coordinates in the rectangle. Any questions?
US is unit square.
Yeah, US is my shorthand for unit square.
Does the order matter in which you put the points in?
Well, if you did t times US, you've got a 2 by 2 times by 2 by 4, and the 2 in the middle matches that 2 in the middle. If you swap these around, you've now got a 2 by...
Which you put in the points.
Oh, no. Just, if I define it as this order, which is what, clockwise, starting at the origin, then the order of the points from my unit, the rectangle, will be clockwise from the origin. Okay?